and still working on section 15.6 triple integrals. Really, it's skill building today. I want to look at how you set up limits of integration, where the region that you're defining, right, the 3D is basically a region, it's a solid chunk of thing in 3D space, is given in quite cryptic terms. Now we know that we need limits for X, limits for Y, and limits for Z, but there's really no one way in which that information can be given to you. It's lots of ways. So here's our first one. This triple integral is E. That's the region that's under this plane, and it's above these guys. So if I take this chunk information and I deal with it, because I can only really draw, most people can only really draw in 2 dimensions. Y equals the square of X looks like that. Y equals 0 is this guy, and X equals 1 is this guy. So what that has given me is I now know the X and the Y limits of integration. Let's see how they go together. Well, you know what you do, you typically choose a rectangle. And if I'm trying to just generate this area, then I'm going to go from X equals 0, which is here, to X equals 1. I'm then going to go Y equals 0 to Y equals the square of X. And now I just need to fit in the Z's. Well, the Z's a little bit easy because the Z is that guy. I guess the only fella that's missing is the start Z value. And it is a number. What number is it?
Would it be 0?
Yeah, and it's kind of cryptic. But see, the minute you say it's above a region, you mean the floor is the XY plane, right? So above it means Z equals 0 and above. If there is no other relevant information that dawns on you, but you know that there's a limit missing and it's a number, the chances are it's going to be 0. Right, now, if you set this fella up, would you agree that it's just, you know, the usual process, right? And it'll come out, and I don't want to really dwell on that. I want to focus, right now I want to focus on how you create limits of integration using that particular guy. Are we comfortable that this generates these two, and then the Z's come later in this particular question? Right. Do you know in other questions, the Z will be numbers and the X and Y's will be the mixed up guys, you know. Every permutation is and will happen. Let me see if I can find the next one. This is question 8, and we're being asked to use a triple integral to find the volume, what they're calling a tetrahedron, and the only information that we know about it is that 5x plus y plus z equals 4. Okay, now, if you imagine what a tetrahedron might look like, it's basically, it crosses the x, the y, and the z axis like that, right? And we're trying to find the volume of this. So I know what the volume is. The volume's 1 of dV. What I've got to do is figure out what this guy is as limits of integration. So one of the ways I would do a shape like this is, can you imagine this shape being, you're looking vertically above it and you're staring downwards. And if you stare downwards, do you see that what you are going to be looking at is what the shadow looks like on the floor? So basically what I'm going to do is I'm going to create the limits for X and Y first. And then I'll figure out what the Z's do, right? So if you look at this equation and you do it on the ground, aren't you basically making Z 0? So what I'm looking at is 5x plus y equals 4. That is negative 5x plus 4. And I'm basically looking at that straight line. And I happen to know that this number is 4. And I happen to know that this straight line is y equals negative 5x add 4. And I wish this was nice numbers. But can't I figure out what the x coordinate is? I think it's going to be 4/5. And it's going to be at 0. Are we comfortable about the creation of this triangle, which is basically going to be that guy there, right? Now I should be able to generate limits of integration here. There's my typical rectangle. In this case, won't x go from 0 to 4/5? Won't y go from 0 to this fella? So y is going to be 0 to negative 5x add 4. And now we just have to figure out what z does. Well, I can tell you right now, I know the bottom value for z because it's a floor, isn't it, 0? But what's the top value for z going to be? Well, here's the clue. I'm going to get it from there. And so it's going to go from z equals 0 to z equals what you get when you range this guy. So what's that? 4, take away a y, take away a 5x. And you're just finding 1 because that gets you the volume of the shape. Right, does that make sense what I just did there? Now, imagine I had a question that looked like this. X squared plus y squared plus z equals 9. And I wanted to find out what this shape would look like, right? What would the volume be? The first thing is make z 0 and project it to the ground. Now you project this to the ground, you see that you're going to get a circle. And then can't you make z equals 0 to z equals 9, take away x squared, take away y squared? So do you see what my strategy in these types of find the volume of a shape? Make z 0, that basically flattens it on the floor. Now you can actually make x 0 and do the reflection on the side wall, right? Or you can make y 0 and make it reflection on the front wall, right? It don't matter, right? Maybe mathematically one of those three is a little bit less work or a lot less work. But just to make my life easy, shining and above, what does it look like? Now, if I was doing this particular question, right? So let's actually do that question. And so it would be find volume of this shape, right? Okay. And we'll make it that it's above the XY plane, right? Otherwise, the volume's infinite, right? It goes on forever. Now, I projected this down onto the bottom, which is what we have. And we got x squared plus y squared equals 9. Now, if I do the z guy, won't the z go from 0 to 9 take away x squared, take away y squared? Great. Now, do you notice something nice about circles? Sorry, question?
Yeah. We're just going to keep it like that? Yeah.
Okay, I will mute all because I don't think I want to hear someone's personal conversation. Here we go. Right, we're back to this puzzle. Do you recognize that that would look really nicer in polar? So why don't we just do that? Just admitting a few people more. Well, if you're doing this in polar, won't you go from theta equals 0 to theta equals 2 pi, and r equals 0 to r equals 3, 1, and it's going to be a dz, and instead of a dx dy, can't we do an r dr d theta? And I don't want x's and y's anymore. So shouldn't that guy actually be 9 take away r squared? So what we've done is we'll find the volume of this shape as it lies above the xy plane. But the triple integral ends up being not in terms of x, y, and z anymore, but r theta and z. And that's allowed. That seemed a useful approach to some integrations where x's and y's don't play well. Because you can imagine what that would look like, wouldn't it? Look like, ugh. But you agree that probably is not going to end well, algebraically. Any questions so far about how to generate limits of integration? Because that's all I've been focusing on. I think if you get that done, the triple integral stuff is pretty much same old, same old. Now this one is question 9, or at least my version of question 9. So you've got this guy. And you got this guy. Now, I don't know if this is going to work, but anyway, we've been asked to find the volume between these two shapes. So this triple integral is essentially going to give me the volume between these two shapes. Looking at it right now, would you agree that we've already got the upper and lower limits for y, right? So I'm going to put them in as x. 72 take away x squared, take away z squared, and this one goes there. But I'm actually going to go and see if GeoBra is going to be our friend here. It might help, and then it might just confuse the heck out of me as well. So I'll gamble on that GeoBra is actually going to be useful. And now I have to leave. I guess I can put that there. Okay, here's GeoBra. I'm going to type in y equals x squared plus z squared. Okay, do you see what that looks like? It's basically, its orientation is a big cone, right? Zooming out to the, in this case now to the right. And the second function is y equals again. And it's going to be 72 take away an x squared. And then subtract a z squared. Boom. Okay, it didn't help. Sorry. It did help with one of the shapes. Actually, it looks a bit like a jet engine, but that's not helpful. Okay. So, plan B. I'm just going to show how to do what's happening algebraically. Trying to visualize some of these is probably not going to work anyway, so I guess I should have just did it algebraically right from the start. Okay, this bit I'm comfortable with. Here's my problem. I have x's and y's, don't I? And I need to know what the limits of integration of the x's and the y's are. Now, when it's a single surface, don't you just make z 0 and project it onto the floor? But when it's between two different surfaces, one of them was a cone and the other looked like some weird cylinder. Eventually, I'm sure that cylinder would have met up. But what you need to do is you need to find the intersection. So how do I find the intersection of these two guys so I can figure out what the limits of integration are? Well, I set them equal to each other. Now, if I add an x squared to both sides and then add a z squared to both sides, I get that. And then I end up with this. And if I draw an xz, that, do you know that cylinder that the 3D thing had? Does that now kind of make sense? If you project it far enough, you'll find the damn thing. That fella is going to be my limits of integration. Now, do you notice it's using the x and z guys, right? Can I use this fella as polar? Agreed? Polar. Now, okay, normally it's x and y as polar, but can't you do x's and z's as polars? It's transferable. And if I do that, can't I say that theta goes from 0 to 2 pi, and that r goes from 0 to 6? And this fella here is going to be r dr d theta. And what's this guy going to become?
R squared.
Right. And won't this guy up here become 72 take away r squared? Now, when you set this whole thing up, would you agree the rest is pretty much plug and chug, right? Setting up the triple integral is by far going to be the hardest task. If you can make this happen, the rest is not that bad. I mean, you're only integrating one. I mean, how hard can that be? And all, sorry.
How did you choose which of the two y equals to go on the top or bottom of integration?
Oh, I just knew by luck that that's bigger than that. That's not a good answer. If I got it wrong, which trust me, because I did it earlier and I got lucky, it will be positive if you do it right. And it's going to be negative if you do it wrong.
Okay,
and so if I got negative, I just made it positive. Now, if bloody GeoBra had worked, the guy that was furthest to the right would have been the big one, right? And the one more to the left would have been the small one. And I could have visualized it, but GeoBra wasn't going to help me. There is a test, I guess you could do. Can you just choose a point here that you know about, like 6,0, and then check it out on both of those, and the one that's biggest goes in the top, and the one that's got the smallest Z value, or in this case Y value, goes in the bottom. So if I did 6, well, actually 6 is a bad choice because it's 0 in both cases. Choose some other point like 1,2, right? If you plug 1,2 in here and you plug 1,2 in here, can you trust me that that's bigger than that?
Yeah.
But 1 squared plus 2. So just randomly pick a point in the region that you know is there. That's not a good choice because that makes both of them 0, so I couldn't tell. But anything inside, I would get it. And I guess what plan B is, if it's negative, just keep your working, but turn it to a plus. Volumes, because they are physical entities, have to be positive. Are we good? Any? Oh, well, thank you for hanging in, because this is, if you're a visual person, this is not too bad, right? So I've got a solution up here that I'm going to show you. This is question 10. I've already put it up, but I'm going to show you the non-solution version first. Y equals x squared, z equals 0, and y plus z equals 1. And it's at find the volume. So we know it's going to be a triple integral of E1 dv. And it's somehow that fella, right, is going to give us all the bits and pieces that we kind of need. So we have to kind of figure out order of integration x, y, and z kind of deal. So if I focus on y equals x squared, I have this fella, right? Which is kind of nice. But I have a problem, don't I? I really don't know. Well, I know what the y's do. I'm sure the y's go from here up here, right? But what I don't know is what the x's are. Do you agree? Right. So I know that the integral is going to go from y equals 0 to y equals x squared. And I know that x goes from 0 to some number. I mean, does it stop here? Does it stop there? So I have to figure out how I'm going to get from this information what the start and finish value for x's are. Is there any obvious way in which we could figure this out?
Can we use the gibbons to arrange into the given function to solve for x?
Yeah. And if you do that, can you trust me you get -1 and 1? Oh, x goes, I don't know why I put 0 there. It's -1 and 1. What about the z then? We need a z, don't we? What's the limits of z going to be?
0 to 1 minus y.
You all happy with where that came from? Just rearranging this guy. And 1 dv. So let me show you, now that we've constructed it, what the solution looked like according to WebAssign. That's what that shape looks like. Now, if you have a brain that's capable of figuring that out, you're a better man than I am. But y plus z equals 1 is actually a flat horizontal diagonal plane. If you look at what does y equal x squared look like, y equals x squared is on the ground as y equals x squared. But can you imagine the piece of paper going vertically upwards, keeping that y equals x squared shape all the way. Now you put those two together and they intersect, and that's where these corners came from, and that's where the 1 and -1 came from. So I'm not sure if the picture actually helps or hinders the process, because the algebra came out a lot easier than that. Here's the solution to well, not actually a solution. Here is a shape, and there are 4 pictures that you need to match. One of these 4 guys represents this volume. Which one? Okay, let me give you a help then. I'm not going to pick that one, and I'm definitely not going to pick that one. Why are those 2, the top left and the bottom right, out of consideration right away?
Your X value is set at 6 when your interval was set at 0 to 1.
Right, so now you're a 50-50 guess person, aren't we? Which is much better than a 1 in 4 guess. So it's either this fella, right? Or it's this fella. Which one do you think it is now?
Top right.
So you're picking that one. Is it a guess or do you have a reason for that?
Well, if it's the y goes from 0 to 6 minus 6z, so z is 0, the y would be 6.
I like your thinking, and yes, that's the right reason. So, I mean, they're kind of clues. You just have to, there's a crime going on here and you're trying to solve it, right? So the algebra does give you little nuances about what is, what to look for. And that's kind of cool. But there isn't a hard and fast, this is the method. It's much more an art, right? You know, each question could be a little bit different. So you have to look at each one on its own merits. Right, I want to now start looking at centers of mass. Okay, and this one is question 13. We're being, the region E has X goes from 0 to A, Y goes from 0 to A, and Z goes from 0 to A, and that the density function is 8x squared plus 8y squared plus 8z squared. Now we've done density, we've done centers of mass in two-dimensional objects, remember double integrals? So this is going to be the center of mass of a triple integral, and it has very similar formula. First thing we need to do is get the mass, don't we? Now for this shape, won't the X go from 0 to A, the Y go from 0 to A, and the Z goes from 0 to A, and it will be of the density function. And since I've decided to do it in this order, Z, Y, X. And these are long questions. Would you agree that this is not that hard to do? It's just polynomials. Okay, you're going to plug zeros and A's in, right? Agreed? You're going to have zeros and A's. I don't know what the answer is. I'm not even going to calculate it. Can we pretend that it ends up being 8a to the 4? Right, imagine integrating with Z, making Z 0 and A, integrating with Y makes Y 0 and A, and then finally integrate with X makes X 0 A. And the chances are it's a big ugly polynomial with A cubes and A squares in it, but let's just pretend it's that. So you calculate the mass with this formula, and then you have to do X bar, Y bar, and Z bar. And they are going to be the same triple integral limits, so I won't actually write them down. What do you think the formula for X bar is going to be? Well, what would it be in 2D? Wouldn't it be X times the density function with 1 over M? Agreed? X times the density function. Well, X times the density function. One over M, Y times the density function. And 1 over M, Z times the density function. Isn't there a kind of elegant symmetry about this whole process? Agreed? The formula for the X bar, the Y bar, and the Z bar. Now, here's a way to save time and money. Can we pretend that I actually did this correctly? And X bar ended up being 4a. I do not need to calculate Y bar and Z bar. I already know what the answer is. What is the y coordinate of the center of mass?
Or A?
And z?
Or A?
If that was the right answer, right? I know I haven't done this, but honestly, it'll take me about 15 minutes to fight my way through this. But can we pretend we did it? Why can I say that they're the same and be quite confident that that's going to be true?
Symmetry.
Symmetry. Isn't this density function symmetric? Aren't these limits equal? Would it make sense then that by symmetry, I only really needed to find one of those three guys? Agreed? Right. Now, I am going to do a baby version of this question that's relatively quick, just so that we can deal with the process. And this one's just got too much work on it. So since I'm doing a baby one, I can be in charge of the limits, right? So I am going to do x is from 0 to 1, y is from 0 to 1, and z equals 0 to 1. And you know, I pick them because with a bit of luck, aren't they going to be pretty easy numbers, right? And let's do the density function. And let's have the density function just be x. Right, so I don't want to make my life too hard. Then to get the mass, it's the triple integral of this region with the density function, dv. In this case, it's x equals 0 to 1, y equals 0 to 1, z equals 0 to 1 of x. And since I said I was going to do it in that order, then I'll do it in that order. Okay, this is not much of a time saver, but technically it could happen in a much better world. Couldn't I, because these are variables separable, couldn't I break this into 3 single integrals? And I would do the integral from 0 to 1 of 1 dx, the integral from 0 to 1 of 1 dy, oh sorry, that's an x, and the integral from 0 to 1 of 1 dz. Are you comfortable about why I could get away with that separation here? You're always trying to find ways to make your life easy. Can you trust me that that's 1 and that that's 1? Oh, sorry, that this is 1 and this is 1 and this is a half? But I should, I guess, put it in. But would you agree that's 1 and that's 1, right? I can do that. So what do we get? We get that the mass is a half. So far, so good? Right, let's find x bar. Well, it's the triple integral. So that's 0, 1, 0, 1, 0, 1 of x times the density function, dv. So it's going to be 0, 1, 0, 1, 0, 1 of x squared. And that can separate and that's 1, and that's 1, and this is a third of x cubed. So x bar ends up being 1/3.
Multiplied by 1 over m.
Oh,
Yeah,
well
shouldn't there be
caught.
two?
Yes. 2/3. Well caught. I've done that before, don't I? Always seem to forget that 1 over m thing. It's a bad habit. We're happy about the 2/3 because 1 over m gets you 2. Right? We're good. So continue. To get y bar, 1 over m. Y times the density function. That's 1 over m 0, 1, 0, 1, 0, 1 of yx. But doesn't this one, since 1 over a half gets me 2, doesn't this one also separate out quite nicely? And this is 1, this is a half, this is a half, and this is 2, and so the whole thing I get is half. So 2/3, 1/2. I know what z bar is. What number is z bar?
It's also
Half.
a half.
Aren't I using the symmetry? Well, it's partial symmetry. Wouldn't it be reasonable to assume that y and z are going to behave the same way because they are same limits of integration and they are both missing from the density function? That makes sense? And that would be the end of that question. Yes,
Go on. No, finish.
I'm good. What do you want?
So, question. So, like, so here we're calculating the center of mass. How come we don't find the moment, like for the x, y, and z? Why don't we find the moment as we did the last time when talking about double integrals?
Well, if you go back and you look at the double integrals, the moments are the x density, x rho xy, and the y rho xy. So we are finding them, aren't we?
No, I don't see the moment. Like, for example, as you wrote, center of mass with respect to y is equal to the triple integral of y, rather than like.
Okay, what would it be in 2D? So imagine it was 2D. Wouldn't the answer be a double integral y rho of xy dv? Well, dA actually. Is that not? So what is the moment here? Isn't it this bit and then you stick in the 1 over m, which I keep forgetting?
Instead of y, it's x.
That's the center of mass. The moment is y squared times density function.
Okay, so the engineers are coming up about us, right? I'm not sure how to answer that because I don't really know what I'm saying. I'm basically saying this is the guy that you use to get the answer. And you seem to have two things. One's a center of mass and one's what the other you said is called a moments. Is that what I just heard? Maybe.
Moments are calculated differently.
Okay, so all you need to do, as far as because I don't know anything about these things, is if you tell me what the formula is, can I get the answer? And it's the engineer who's saying, like, I want the center of mass, I want the moments, I want whatever the thing's called. So I'm assuming that I've given you the right one of the set here.
Yeah, you have.
I have. So we go with that. Yeah. I'm just looking at their solution. Well, it's not a solution to the question I've done. What's the function here? 9y. You want an, oh, okay. The guy that they call the moment yx, right? That guy there, the moment yx. He's the guy that has the z density function thing going on. So it looks to me like that guy is basically just another way of saying the z bar part before you stick the 1 over m on it. I don't know if that's true or not, but maybe it is, maybe it isn't. Think. Are we okay with getting x bar, y bar, z bar the way I told you? And I'll let you figure out, because I'm not really an expert and I don't want to say stuff that's just wrong. What on earth that means in another world. I'm trying to see if we got any other interesting one to send up. Okay. Writing down the beginning of question 12. We have a z equals 1 squared. That's a cylinder. Okay, I'll take the word for it. There's an x plus 4z equals 4. There's an x equals 0, and there's a z equals 0. And the bit I'm not going to have time for is the density function. So let's go and look at this guy. I'm going to figure out what the heck the limits of integration are going to be for this story. Have we got any, oops, I'll put the solution up so I don't screw up. Right, I need this fella. Eventually there's going to be a density function in here. As I say, I'm not even that concerned about it. How are we going to break this shape up? Well, let's look at this guy. Doesn't have a matching guy there. So I'm not even going to try and think of what that looks like in 3D, but would z equals 0 to z equals 1 minus y squared? Does that look okay? Are we good with that one? Okay. What about that one? If I put these together, couldn't I rearrange this as x equals take away 4z and x equals 0. So I could put x equals 0 and x take away 4 4z. So who am I left with?
Wait. From the first integral, you got rid of all the z's.
Ah, good point. Well, I'll finish this off and I'll see if I can fix this. So I need a y equals somewhere, a y equals somewhere else, don't we? Well, if I look at this one here, and I do a y z fella, one minus thingy look like that. And if z goes from 0 to up here, that's the region. So won't that guy give me what my y should be? And my y should go from positive 1 to negative 1. Now, when I look at these and someone's already noticed it, with the exception of the y values, don't we have a problem about the order that I did these to? And he noticed quite clearly that isn't this one going to introduce z's, but the z's are all gone. So how do we fix that problem?
We could sub and solve.
Or you could do something even less, I mean, I'm not saying that wouldn't work, but we could do something a lot easier than that. Yeah. Just swap them. So when I've done these, won't the x's have disappeared? By the time I've done these, right, won't the z's have disappeared? And then won't I just be left with some y's that this can deal with? So I don't have any contradictions. In this case, however, I'm using the z's and then later on they appear. That was a good sign that that was probably the wrong order. So if you get the limits sorted out, you can then shuffle the cards a little bit if necessary. And in this case, the shuffling of the cards was switching these two guys around. Yeah, the back of my brain is